Now we will talk about inverse functions. Inverse functions are functions that undo an original function. To do this, we will first switch our x and y's. So for our first example, instead of y equals 3x plus 1, we'll say x equals 3y plus 1. Then we will solve for y by subtracting the 1 and dividing by the 3. This is the inverse function of my original function. I will note this by putting a negative 1 on the y. I can check my inverse function to see by plugging a point in my original function. If I put in 0, I get out 1. If my inverse function is truly accurate, when I put 1 into it, I should get out 0. 1 minus 1 over 3. Yep, 0. For my second equation, I'll start by switching x and y, then squaring both sides to get rid of my square root. Now subtracting over my 1 and dividing by 5. This should give me the inverse function, the function that should undo my original function. I note this by putting a negative 1 next to my y. I can check to make sure I've done this correctly by picking any point I would like. Let's say we were to put 2 into the original equation. 5 times 2 plus 1 is 11. I get out the square root of 11. Now, if I put the square root of 11 into my inverse equation, I should get out 2. The square root of 11 squared is 11 minus 1 divided by 5 is 2. Yep, I've done the work correctly. My point is flipped. Now for my last example, I switch my x and y. I add over my 4. I take the square root of both sides to get rid of my squared. And I subtract over the 1. Notice that you're finding the inverse equation, what undoes the original. By doing this, I'm undoing all of the operations in my original function. Remember to put your negative 1, that notes an inverse function. Now I can check. Let's say we were to put 1 into my original equation. 1 plus 1 squared is 2. Squared is 4. 4 minus 4 is 0. Now, if I put 0 into my inverse equation, I should get out 1. Let's see. 0 plus 4 is 4. The square root of 4 is 2. And 2 minus 1 is 1. Perfect.